And we're live. So, hello everyone. Welcome again to day two of the Device Authority Virtual Summit on the theme of Zero Trust in the age of AI. My name is Richard Seward. I'm the Vice President of Product Management here at Device Authority. And as you can see from the slide in front of you, today's session is focused on IoT and AI in healthcare. The healthcare field is rich in both value and complexity. It's something like 9% of global GDP is spent in healthcare. And even if we constrain our focus just to IoT, it's rich in complexity and devices, from edge devices at the bedside, heart rate monitors, through to surgical robots, through to sort of, should we say, the middle office of ultrasound scanners and MRI machines. And finally, we have, if you're the back office of the industrial manufacturing, making everything from paracetamol tablets through to those surgical robots and MRI machines. To explore the space, joining me today is Anthony Moffa from PTC. Anthony has a detailed knowledge of the challenges and opportunities in this space, from decades spent in leadership across production engineering and product management, also including his practice as a Lean Six Sigma Master Black Belt. Before I hand over to Anthony, I just want to let you know there will be a Q&A session at the end, so please do put your questions in the question widget at the side. Without further ado, Anthony, over to you.
Thank you very much, Richard. Good morning, everyone. Good evening, good afternoon, depending on where you are on this digital world. My name, again, is Anthony Moffa. I am part of PTC's IoT program. I've spent a number of years in the IoT space, dabbling with it back in the 80s and 90s with modems, and actually being a practitioner for a fire and life safety company, as well as a medical device manufacturer. And for the last 6 years plus, I've been at PTC, helping other people do this, go on this connected journey. So let's do a very quick introduction on who we are as PTC. PTC got its start in the world of CAD, and it was Pro E at one point, and it's now Creo. But from that genesis of a CAD company and a 3D CAD company, we began this journey towards completely encompassing every aspect of the digital thread, everything from the design to the push into PLM, into manufacturing, and from manufacturing into service and the service lifecycle management. So we're very broad in that aspect. Now, what does that mean to you? Most people don't know the name PTC. They don't associate it with products. But in your day-to-day life, 100% of the Fortune 500 companies in aerospace and defense use a PTC product, one or more of those. 100% of the Fortune 500 industrial machine companies are using PTC products. And the same thing with medical device companies, right? So as you look at this, in your day-to-day activities, you have probably encountered one or more products that were either designed, manufactured, or currently being monitored and serviced with a PTC software product. That's the world that we live in. I kind of say to some people, you don't know us for medical devices, or you don't know us for this, but we make those things better. As an overall company, we're a $20 billion market cap right now, $2.1 billion in sales. We are about 7,000 employees, and we encompass over 35 years of history, going back to the early days of CAD, and obviously a number of innovations that are existing in our world. Our customer base is very broad. We have 29% in the industrial space, but you can see 16% in federal and aerospace and defense, 12% in life sciences, 11% in automotive. So we have a fairly broad footprint. You can see some of our customer portfolio here of John Deere, Volkswagen, Airbus, Medtronic, and so on. And again, they may use one or more of our products, not just one. Now, I alluded to the fact that we are in this world of an entire ecosystem, from the thought process of design through the end process of servicing a product. And so if you look on our life cycle here, our infinity diagram, if you start with design down here in the lower left-hand side, and then you move that into production, and then how you operate it, how you monitor and service, all of that is, we're all familiar with this, but what we're getting into now is the other piece of this equation, which is, once I've serviced it, providing that information back into the planning and design process. So getting the product managers as well as the engineering staff involved in the process of return on what they're doing. Prior to this, it's been a sneaker net, right? If a technician tells somebody and it eventually gets to product management, great, you've got the feedback. But now there is a complete thread that brings that data back. Our headquarters are in Boston. I am in the Boston office, but we have operations in about 35 countries around the world. Now, today's world is a very tumultuous environment in the business world. I think at the core of all this is right in the middle. Software is driving everything, right? If you think about your product today, your product is probably a delivery mechanism, and software is what is giving the service or the value to your customer. So, given that that is the case, it's obvious that all of the things that we're doing are now becoming digitized, becoming connected, becoming integrated. And that opens up a whole world of opportunity in terms of us as a business expanding, but also for other peoples to infiltrate what we do and attack what we do. We've seen with the COVID days that the supply chain has to be more dynamic. It has to be tied into our day-to-day activities. We're seeing that, for example, 10,000 baby boomers are retiring every day. And we now have a new workforce who has grown up in the digital world. In fact, the current generation, my kids are in their 20s. They're no longer kids. They're young adults. They are the first generation to have one telephone number for their entire life. You think about that. For those of us who grew up with the dial phone on the wall, and every time you moved, you got a brand new phone number. That is no longer the case, right? So there is now a digital history for you tied to that one cell phone number for the rest of your life. And that world, because they've grown up in that, they expect everything instantaneously. Everything is at your fingertips. So if you think about the B2C world where our Amazon has told us this is all about you, this is everything you've ever ordered, that is now being driven into the B2B world. The B2B world wants that exact experience, and this new workforce coming in is coming in and saying it has to absolutely be there. At the end of all this, on the right-hand side here, there are two things that are really starting to change how we operate in the service world, and that is service is becoming a moving from a cost center to a profit center. And that's a huge change for a number of companies. It's always been the back end, but what they're realizing is that service has a significant component of growth because products that last for 5 to 10 to 15 to 20 years have anywhere from 3 to 10 times the value in service that they did as an initial product. And the last piece of this equation is we're becoming focused, and I don't want to say focused, but we're aware now that environmental stability is an important piece of the process. And if I'm constantly in a world where I dispatch somebody to diagnose a problem as opposed to diagnosing remotely and then dispatching the right person with the right parts, I have not only a service optimization challenge, I have a sustainability challenge from an environmental perspective. It costs me money to send people, I burn fuel, and I waste time and resources. So as I said, we have this ecosystem of a CAD and an ALM and a PLM and a service lifecycle management. But what I want to talk about today is this piece in the middle, the digital connects the physical world, because that is the piece that really informs the service technician as well as the engineering organization what is going on with their products in the field. Now, we break this connectivity into two different arenas because it really addresses there are two different consumers of that data. For example, on the top one here, let's look at manufacturing. We've said we have CAD that takes us through this environment here, and eventually our product lifecycle management software will release a bill of materials for manufacturing into the manufacturing environment. And for those of you who maybe know the terms, There's an engineering bill of materials or an EBOM. There's a manufacturing bill of materials or an MBOM. And there's even a service bill of materials or an SBOM. So if you hear me use those terms, that's what I'm referring to. But the MBOM comes into manufacturing, and then they figure out how they need to manufacture this device. Well, we start monitoring those manufacturing pieces of equipment. We look at a manufacturing line, and we can take data off of the PLCs, and we know the operation status of that manufacturing line. Now, one of the big things that we care about in manufacturing, obviously, is quality, but we also care about throughput. And there's this balance of how fast can you run a line and how good is your quality. And when you measure all of those things, you can determine what your efficiency is in your environment. Now, one of the challenges in manufacturing very often is shift changeover, unplanned downtime, maybe because a machine didn't have the maintenance it was supposed to have, or we ran out of material, so on and so forth. So when you start to add that into the mix of things you monitor, why you have downtime, now you get to look at more efficiency and how you take some of that out. Maybe you need better tooling, maybe you need a better maintenance process for your product, or maybe you need faster changeover and shift changeovers and line changeover methodologies. Now, when we move down to the service side, it's an interesting dilemma here in service. The relationship between product engineering and manufacturing is generally very good, very cohesive, because the two are co-located or near co-located, and they are very much a symbiotic relationship. What engineering designs, manufacturing has to make. If manufacturing has a problem with that, there's usually a direct feedback to that. It tends to be more distant in the service world. Some people might say dysfunctional, and it, at times it can be, but we're working to close that gap now. So now we're looking at the service side. We'll get our service bill of materials, but what we care about is down here, what's going on in the service world, how the customer uses the product, how our services overall is being executed, and what the product itself is doing. If you take a product release, and we would do this when I was on the manufacturing and engineering side, you take 2 or 3 or 5 or 10 pieces of equipment and you run them through a series of tests, and that gives you an example of what's going on. But in this world, we're talking about tens of hundreds or tens of thousands of assets providing that feedback. So instead of a controlled environment where I'm taking everything into consideration, I have an uncontrolled environment. I have the real world example of what my product's doing. And that feedback, that information is invaluable to the engineering group because it shows them things they never thought would be done, how customers use the product and even abuse the product. So when we talk to customers about this, there are obviously values to connected services. There are value returns on connected manufacturing. And these are generally sizable. We're not talking a 1 or 2% change in business operations here. We're talking tens of percents changes. So for example, in service, your first time fix rate might go from 60 or 70% to 80 or 90%. That is huge because first time fix, it's from a negative perspective, it's the gift that keeps on giving. Generally, if you don't fix it on the first visit, it's 1.6 more visits to go do that change. So if you can get one more fix done, you actually saved 1.6 on that transaction. On the manufacturing side, you're looking at optimization in assets. We generally see between 20 and 30%. So if I were to break this down into the common things that we see, by doing this monitoring, by keeping track of this equipment, we reduce our downtime and our maintenance costs. For those of you who know, when you do time-based maintenance, time-based is statistically laid out to say average person uses the equipment at this rate, so therefore we do maintenance every 3 months or 6 months or 9 months. But when you talk about monitoring a piece of equipment, now you know when it's being used and how it's being used. You can change the way that you do your maintenance. We see improved operational efficiency because when maintenance is done right, the equipment is running more effective and more often. Obviously, customers are satisfied. There's an interesting thing here as a service organization. When something breaks, it doesn't cost me any more money to fix it on Monday than it would to be Friday. Now, maybe if I have to rush somebody on a plane, yeah, there's a little extended cost, but the real cost is actually on the customer side. So if a customer is down for 3 hours or 3 days, it's a huge impact to their business. So when I can do things faster and more efficiently, my customer is absolutely satisfied because their uptime is changed tremendously. That feedback loop allows us to enhance the product design and serviceability. Now, that is everything from design for manufacturing, design for assembly, and design for service, not just one, but all of those. And it also gives us an opportunity to change our business model. Maybe we want to work off of a per use model. We have some customers who have gone from selling equipment to selling outcomes. You use this so often, but let's say that you're in an environment, take a printer and you have ink in a printer. There are business models now where you sell the printer relatively cheap, but you sign people up for ink consumption and you mail them their ink every time they need it because that monitor device tells you when it's running out of ink. If I look at this connected infrastructure, what it is all based on is our ThingWorks platform. So we have a set of core data services here. Now, those data services mean everything from I can monitor data coming in from devices to I can provide remote access and control capabilities like a desktop share, for example. It could be used in a digital mentor capacity where I watch what a customer does, or it could be used in a capacity of me going into the device and making changes for a customer. We have software update capabilities where we can push updates out to assets rather than sending technicians to do that job. And we could do file transfer capabilities. Those are all core. Now, file transfer is an interesting one because older equipment, the brownfield equipment that's out there, may not be smart enough to tell me what it's doing. So I may need to be more introspective and pulling data out of it. And a lot of times engineers will write into log files. So on the services side, we expose all of that data through our Smart Connected Product Accelerator. It's basically a user interface that shows our customers their assets, where those assets are located, and the condition of those assets. And every asset has its own page. So I can look specifically at an asset to see whatever monitored properties I'd like. So for example, maybe I'm monitoring RPMs and current draw and voltage and vibration. All of that information would be displayed. Not only is it displayed, we can set limits on those things. So if they are above or below a limit, they can be identified as being problematic. In the manufacturing space, we have a bit more focused set of applications here. For DPM, that's more for the manufacturing engineer looking at the management and performance of a line. So this might be where, on an average day, you have 8 hours of operations. You may find that in a day, you only 6 hours of that day is actually operating, and 2 hours might be consumed with line changeover, changeover for shift 1 to shift 2, or it could be for unplanned maintenance, right? But knowing that, measuring that, and seeing that now gives you actionable intelligence to decide how you want to operate, how you need to change that operation. Connected Work Cell, or CWC, allows us to push information to the floor so that an operator can see how to do the job that they're supposed to do. It's obviously very well suited for an environment where it is one-off or very custom applications, or where line changes happen or batch changes happen on a regular basis. And then there's AMU, asset monitoring utilization. That's really monitoring for the service needs of a product. So if I do that and I do good maintenance, I obviously keep my line up and running. Now, we don't restrict you to that. There are capabilities for our customers to build anything that they would like to build for their environment. So there are custom solutions in there. Now, the service world is different than the manufacturing world. In the service world, we're talking about hundreds or thousands of locations with 1 or 2 or 5 or 10 assets at those locations. Whereas in the manufacturing world, we're really talking about a physical location that may have 2 or 3 or 5 lines, and in each of those lines may have 2 or 10 or 15 pieces of equipment in the line. So it's a different configuration on how that's done, which means we have a variety of connectors to get data from these locations into our environment so that you, as the end user, can use that data, can utilize it, review it, and take a look at it. Very quickly, we can do our deployments in multiple ways. We can do it as a PTC cloud hosted environment. We can do it as an on-premise as a customer would, everything enclosed. And this tends to be in manufacturing environments that follow the Purdue model. The Purdue model says air gap your manufacturing so nobody can touch it. And then there's the client cloud where the client may be hosting in their own private cloud, or they may be using one of the providers like Amazon or Microsoft Azure as their hosting environment. In the cases where the cloud environment is in place, you have on-site monitoring of equipment, and that means this data is going to traverse the internet. This right here is all isolated, but this here and this here, we are going to have to take that data and send it over the internet. That means now we need to talk about securing that infrastructure. IBM and Verizon released a couple of studies, and these should kind of make you sit back and say, wow, that's pretty depressing when you think about it. That the bottom one, most likely 240 days to identify that a breach has occurred, and another 88 days to contain it. So on average, 328 days, nearly a year to identify and contain a breach. That's why, for example, you'll hear that companies have announced they've had breaches, and then they will tell you when you look at it, say, well, that breach happened a long time ago. That's where that number's coming from. Now, breaches generally involve human error. Somebody has done something, clicked on something, done something that they shouldn't have. Years ago, that was a significantly higher number. It was in the 90s. So that may very well be attributed to a large number of organizations today starting to train their people on things like phishing emails, right? How to avoid those, how to identify those, and how not to click on those things. 55% of these involve compromised credentials, and then 85% of the critical errors are caused by developers and system admins. Basically meaning you may have used a piece of software that has a compromised component to it and didn't realize that, which means on the back end here, security, monitoring of our equipment and our software, as well as making patches, becomes very important. And it kind of ties you back into why we have software updates in our product, because it's critical to continually push those updates out. This is a fairly big eye chart here, but when you think about this, if I look on the right-hand side, how do I attack the world of the Internet of Things? And IIoT is the industrial internet. So it tends to focus itself more in the manufacturing world than it does in the service environment. But if I look at physically tampering with devices down the bottom right-hand side here, getting access to a device to do something to it. This may not necessarily be your employee in your organization. It could be somebody outside of your organization that has access to that. But, it's the one that a lot of people will say a disgruntled employee did something. Compromising endpoints. This has been a big one for people who have had home security and nanny cams and things of that sort. They want the accessibility and they want the visibility into their devices. And in many cases, they don't understand the security component of it. So they literally have no security on their devices. If you think of Wi-Fi, Wi-Fi in your home, there's a reason why you can hide the SSID, and there's a reason why you have encryption on that, why you have a key to get into your device, because you don't want to give everybody access, because when they do, they can get into your facility. It's not so much they're stealing your bandwidth, which obviously they can do, but at the same time, they have access to your things. They are on your network. So compromised endpoints is a big access. There are vulnerabilities in devices. Back to software maintenance, right? Keeping software up to date. Every day there are vulnerabilities announced, and every day organizations are working to respond to those and react to those vulnerabilities. And then there are things like customized malware. If you think there's a combination here, for those of you who remember the WannaCry virus situation, where there was a vulnerability in the software operating system used in the hospital, and there was customized malware that got access to that vulnerability and then took control of those machines. And basically, it was ransomware. And that takes me to the left-hand side of this chart. It was monetary gain. They were specifically after monetary gain. Now, you could say they were into disruption. They wanted to disrupt the flow of service to healthcare patients. And by doing that, they made it very, very important for them to say, yeah, I want my system back, so I'll pay you the money. So it was a motivator for that. So I generally will come back to, yeah, there are some folks who out there, hacktivism, for example. I want to prove a point, and they may very well break into a system to try to prove a point. But very often what we see in the world today is there is some type of monetary gain involved in this, or on the far left-hand side, I want to gain your proprietary information because I don't want to reverse engineer your product. I just want to steal your ideas. So the realm of this means if we don't protect our environments, we are in a situation where we can lose everything that makes our business work and be profitable. Now, if I were to look at just what the IoT piece of this, our services side is down here. Our manufacturing side here uses our Kepware solution to take data from the PLCs, and we would be sending that data, that telemetry data, right into ThingWorx. Now, there is an encrypted connection here, no doubt about that. But in the normal environment, and I say normal, it's kind of been the generally adopted environment, it's a one size fits all. So what do I mean by that? Well, if there were 10 manufacturing facilities in place here, or there are 10,000 of these medical devices in place, the one size fits all model is every device out at the edge has the same certificate on it. It's just copied from device to device to device. What that means is I have no authenticity of an individual device other than what the device may tell me. Now, a device has a model number and a serial number. So you may say, well, I know the device is authentic because it gave me a model and serial number that matches up with things that I have. Okay, that's reasonable. But how do you know somebody didn't copy that onto some other device? Right? How do you know you didn't take that information and put it on a device that is now intended to compromise your environment? And the answer to that question is you really don't know. So this is where device authority came into the solution scheme for us. By leveraging Keyscaler, we're now able to authenticate that device, and then that authentication produces a unique certificate down at the edge, and then it informs ThingWorx as to the authenticity of that device. So now when a device decides to send me telemetry data, my first step is to authenticate that device as a unique device rather than the other process, which is, hey, we all got the same cert. Let's let you in. So in that process, how that works is the device comes online and it goes up to the Keyscaler server and says, hey, this is who I am. Now, we've pre-populated that server with a list of, think of it as a guest list for a party, right? You're trying to get into a backstage at a concert and you're on the guest list, you get in. If you're not, you don't get in. So we have a list that is pre-populated into Keyscaler, and that allows us to then, as the device comes in, Keyscaler says, yeah, you match up with the device that I was told would be here. Then it's asked to create a key. A CSR is sent up to Keyscaler. Keyscaler then works with a partner like Entrust to do the signing. And then that signed certificate goes back to the device. And the device identity is shared with ThingWorx. So now when I do this connection, not only am I doing a TLS connection, I'm doing a mutual TLS connection, and I have a unique device being identified for me at the end. There's no longer a situation where I can compromise this. There are other features in here where, for example, if you tried to copy this cert and put it onto another device, it wouldn't work. Right? There are features within the Keyscaler world that would allow us to completely identify a device and make it incapable of being spoofed in terms of a copy, a pure copy. Now, am I going to say to you that this is the end all be all? There are no threats to us. No, I'm not. I'm not that naive to say that we're in a no threat condition. But what I am saying is that we are in a much better situation now than we are with a single certificate in place. And you say to yourself, well, why haven't people done this before? Well, there's an opportunity. People have done this before. The challenge with this, though, is that if you did this before without Keyscaler, this was a manual process, meaning you would have to deal with tens of thousands of certificates for tens of thousands of assets. That becomes a lot of work, number one. And number two, we're human. We make mistakes. And quite frankly, you can run into a situation where you've identified the wrong things, you've blocked out the wrong things, you forgot to add things to the system. So automating this process makes it keeps it secure, but it also makes it more affordable and operationally efficient for the organization. Now we can do the same thing in the manufacturing environment. The difference here is that rather than the individual devices having a key and cert, it would actually be done on the Kepware server, because that's the device that's literally talking to the ThingWorx environment. So think of this more as a gateway device to the individual pieces, whereas back in the service world, we're more a one-to-one relationship. Now, as a rule of thumb, that's generally the way it works, but you could be in a gateway in one or the other. So, but generally speaking, one-to-one in service and many-to-one in the manufacturing environment. So if I look at that from my service world, my many assets are going through Keyscaler to be authenticated. It's being told, sent up to ThingWorx, that here's your ID for your devices. And then from there, my communications become very secure, identifiable down to the individual device. On the smart connected operations side, where it's in our cloud, same type of scenario. Again, it's more the site is being authenticated, not the individual assets. And then if you get into the operations world, where it's either on-prem or it's a private cloud, the on-prem is on the left-hand side, where ThingWorx is local to you. And then in the on-prem environment, the data center remote, it's the same as whether it's us or not. Now, in this scenario, I alluded to this earlier, that Purdue had this manufacturing model that said, hey, by the way, air gapping your systems is the best way to keep them secure. And obviously, yes, if you don't expose any of your information to the outside world, then you keep the environment secure. The challenge with that came in 2020 with COVID, where manufacturing organizations found out that, for their people to monitor and have access to and visibility into their systems, they needed to be on site. Now, manufacturers had people on site because they physically had to run machines, but they were trying to reduce the number of people on site, so they're keeping other people off. Well, this now has started to change in the manufacturing world. And so their challenge is to embrace that Purdue model of air gapping without physically air gapping. In other words, let me get connected. And this is where Keyscaler comes in, providing that capability to have a secure connection, identified connection, without having to deal with the downside of air gapping and leaving that data isolated. So a real world example here, and that this will kind of bring us to the end of this. one of our customers came to us. They're a medical device manufacturer, and they have high frequency ultrasound technology. They're rolling out a new system, and it's an interesting change. And there's a reason why this is interesting for them. What we typically find with a number of our customers is security is important to them, but it's not the number one thing on their list. It's generally towards the bottom of their list, to be honest. I think some of that is because they assume security is part of the process. But in this particular case, there was a gentleman on this team who had deployed software in an IoT application years ago for a different medical device manufacturer. And he was very adamant and vocal about the need for security. So security wasn't at the bottom of their list. It was very close to, if not the top of their list. And it was one of their major concerns. What they wanted to do, they wanted unique individual identification. And so in order to do that, we got into a discussion with Device Authority about how do we do that? Because Device Authority had actually integrated with ThingWorx already, but this was something that was a different type of connection that we were making. So we had to work with the Device Authority team, an external partner of ours, as well as our internal teams to make all this come together. So what we're using here is the PTC ThingWorx Remote Service Edge. That's what's our connection component. We have our Smart Connected Products Accelerator in ThingWorx, which allows us to visualize that data. And then Device Authority's Keyscaler is being used for the certificate, the unique certificate generation and identification. And all of that comes together in our environment. Now, we say here that we did this rollout in 16 weeks, and that's true. We did a 16-week rollout to do this. There was work done up front to identify what the requirements would be. But I want to put this in perspective for everyone listening. The average IoT rollout is anywhere from 12 to 24 months. There's a large range in there, right? Because a rollout of an IoT platform and program involves not just the technical aspects, not just the business use case of it, but it's also how do I integrate this into the day-to-day operations? How do I make sure that I have the data that I need, so on and so forth? And how do I get my organization to accept this, right? Internal adoption is a huge thing. But this was done in a very compressed, and it wasn't rushed. It was very well orchestrated, very well thought out, and done very quickly. So as customers run out 5,000 assets, they want to expand to an additional 7,500 assets. I'm going to say one thing I didn't say is their main use case in all of this wasn't necessarily monitoring the asset. It was actually updating the software. They had three options for updating software. One, which is put a man in a van or a woman in a van, send them to the device and have them update the software. It's time consuming. And from a sustainability perspective, not quite that sustainable. The second option is send a thumb drive to your customer, have it installed in the device and have the customer do the update. Well, sustainability wise, it's a lot better, but timing wise, you don't even know if the customer is going to do that, right? So the optimum way to do this was the remote update. So that is their core for this. And that's why that's what drove them to do. And again, they wanted to keep these things unique, right? As a result of that. But the combination of this now allows this customer to do exactly the thing they want to do. They can monitor, they can update software, and they have the assurance that it is the device that they intended to connect and only that device. And the really nice side of this is, let's say that the device is compromised or assumed to be compromised. In this model, that one device can be shut off. In the old model, the one size fits all model, all devices have to get shut off, right? You have to shut down the ingress for everything because you don't know which one is which. So I hope that helped everybody today. I'm going to go to questions if there are questions now.
Thanks, Anthony. We've got a few questions in the chat. So first one is a more general, high-level one, Anthony. Are there any particular verticals that PTC are strong in? Or perhaps you could give some example assets, or maybe rather than just where you're strong is where you're seeing significant growth.
Well, one of the areas that I'd say we are actually very strong in is the medical device space, which is interesting because obviously it's the most difficult one to work in, right? It is a very regulated environment with protected health information being a compromised component here. So that is one area that we're very strong in. But we do have a good play in electronics, high tech, and also a good play in industrial. What I've started to see is a change in the industrial space. Again, the manufacturers are starting to come out of that. We don't want to be connected to the internet anymore. They're seeing the value in the connectivity component. So we are seeing them change their mindset rather than being isolated systems. They're becoming more integrated systems. And we're seeing kind of growth across the board. But the interesting thing is that a recent study showed that only, and I'm very surprised by this, but only 56% of OEMs currently have an IoT program in place. That means 44% are the late adopters waiting to do something. So there is still a significant portion of the market which hasn't moved into this environment yet.
Got it. Thank you. Second question then is, with these kind of deployments, can they only consider new devices? So if you're a greenfield deployment, or is your approach, are you able to look at brownfield deployments with the new and old?
That's a great question, and a very generic response would be you can do either. Now let me clarify that, right? The question for the organization is how valuable is the brownfield asset base to you, right? Let's say that you make 10,000 assets a year. You might decide that making 10,000 assets a year and connecting 80% of those 10,000 every year is all you need to make a change in your business. But if your devices, let's say you make 10,000 and you have 150,000 already in the field, there's a compelling story to say, I do want to connect my brownfield devices, right? I need to consider connecting those brownfield devices because they're the significant body of assets that I need to maintain and service. So that really becomes the question number one, where's the business case for this? No, that being said, your older equipment may not provide any information or useful information, right? So the second step in this process would be, okay, maybe it doesn't tell me something, but is there a log file or are there log files that I can extract from that device? Is there value in me doing a remote connection to that device to diagnose it, right? So can I do a desktop share and do diagnostics? If all of that is accessible to you, then brownfield is certainly something to consider. The last piece of the equation then is, well, if it costs me $10,000 to connect a brownfield device, but a field visit is 500, maybe I don't want. So, can we connect to them? Absolutely. The business case is something that you need to determine and figure out for your organization.
Got it. Makes complete sense. Well, look, that's it on the questions. So what I would like to say is Anthony, thanks so much for showing us that it is actually possible to securely close the loop on product lifecycle management. And this has got multiple benefits, everything from reduced maintenance costs all the way through to new business models and all points in between. Thanks also for showing us that deployments in 4 months are possible in a world where it's 12 to 24 on average. So definitely setting the benchmark there. And finally, also for that point about 44% of OEMs still yet to get into IoT. I think that's a call to action for many of the business development managers out there.
Yeah.
Well.
And I'd like to say, one of the things that I'm focused on is I want this to be easier for people to do. And so I've said to folks, I have a 10-10-10 vision, and that 10-10-10 vision is to get to 10 months to 10 weeks to 10 days. Right. People think that's an audacious goal, and I'd say maybe it is, maybe it isn't. But if I only get to 10 weeks, it's better, or the point is I want to set a goal that's tough to achieve.
Yep.
Because any improvement that I make is going to be good. I just don't want to see incremental improvement. I'd like to see a step change in this. So, that's where we're headed. And Working with customers like we did on the ultrasound machine was great because it challenged us to do better. And I think we've learned from that, and we can do better the next time.
Yeah. Well, selfishly for me, and I guess for my device authority colleagues, it's great to work on these opportunities with you and with your teams, Anthony. So thanks again for your talk today. Thanks also for reminding us the term sneaking it. I haven't heard that in a while, so it's good to bring back in. And then, yeah, out to the audience, thanks for joining us. And just to point out to you, the next session is on cyber resilience starting in 15 minutes time, 3:15 UK time. But Anthony from PTC, thanks again for your time. Really appreciate it.
Thank you very much, Richard. Great to be here.